Welcome. Let's look at some examples for the converse of the Pythagorean theorem. We are going to take a look at some examples where we are given the side length and we want to classify the triangle as either acute, right, or obtuse. But we do have a strategy for that. If the given lengths, if they fit the Pythagorean theorem, then we can classify that as a right triangle. If a squared plus b squared is actually greater than c squared, then we can classify that as an acute triangle. And if a squared plus b squared is less than c squared, then we can classify that as an obtuse triangle. Let's take a look at example A. The first thing that we want to do is we want to identify the length of C, which will always be the greatest of the three, which will be 11. And the other two lengths that are left, let's call them A and B. The order does not matter. So let's call 2A and let's call B 10. Now let's set it up. Let's see which scenario do we have. So we'll have 2 squared plus 10 squared, but we do not know if it's going to be equal, greater, or less than. So let's put a question mark and let's place c squared on the right. So now let's simplify. 2 to the second is 4 plus 10 to the second is 100. Now let's bring down the question mark. And 11 squared is 121. On the left-hand side, we have 104. On the right-hand side of the question mark, it's 121. So now, based on the values that we have here, we can see that 104 is less than 121. So we can conclude that we have an obtuse triangle, because we have shown that a squared plus b squared was less than c squared. Now let's take a look at example 2. Let's start by finding the value of c. C is the greatest value given, which in this case is 7. So let's call that c. And for a and b, the order does not matter. So 8, let's call it a, and 5, let's call it b. And now let's set it up to see if we're going to have an equal sign, a greater sign, or a less than sign. We're going to have a squared plus b squared. We'll have a squared plus 5 squared, which do not know what's the scenario that we have, so let's put a question mark. And then we'll have 7 squared on the right-hand side. So now let's simplify this. 8 squared is 64. 5 squared is 25. We do not know the scenario, so let's keep it as a question mark. And 7 squared is 49. Let's simplify the left-hand side. 64 plus 25 is 89. Let's bring the question mark. And on the right-hand side, we got 49. Now let's take a look at the values that we obtained. 89 is greater than 49, so let's write that down. So we can conclude that we have an acute triangle, because we have shown that a squared plus b squared was greater than c squared. Let's take a look at one more example. Let's start by identifying the value of c, which in this case, we can see that it's 10. That's the greatest value of the three. And for a and b does not matter. So a, let's call it 6. And for b, let's call it 8. So now let's figure it out if we're going to have an equal sign, a greater sign, or a less than sign. So we'll have a squared plus b squared on the left-hand side. So that will be 6 squared plus 8 squared. We do not know the outcome, so let's put a question mark. And c squared on the right-hand side. Now let's simplify this result. 6 squared is 36. 8 squared is 64. Let's bring down the question mark. And 10 squared is 100. Let's combine the values on the left. That's going to give us 100. Let's bring down the question mark. Let's bring down the 100. Now let's look at our results. 100 is equal to 100. So we can conclude that we have a right triangle. We have shown that a squared plus b squared was equal to c squared.
Hello, if you would like to continue learning about mathematics, you can check out the videos on the left.